morning everyone. First, Nadendra Kumar. Welcome to this workshop which is being sponsored by the Scheme for Promotion of Academic and Research Collaboration between the academic institutions, that is between University of Hyderabad and Macquarie University, Australia. So in this particular part of the collaboration, there are a series of workshops, seminars, course deliveries, and other activities which will strengthen the both the institutions' teaching learning capabilities as well as some kind of outcomes will be coming from the research that we are going to do for the next 2 years. So in this workshop, actually this is some of the participants are from IEEE, and I suppose there is no confusion for you. It is basically a jointly organized workshop, so you can take the utmost benefits from this particular workshop. The first workshop is basically focusing on something developing on the smart sensing systems, with this particular title called as Intervening Social Perception in the Estimation of Air Quality Indices among the Particulates. So the basic objective of this project, which has been sponsored by the SPARC, is given in terms of 4 objectives. The objective 1 is design and development of a low-cost, robust, and flexible IoT system to measure the air quality indices augmented with social mindfulness in the real time. So, in a nutshell, basically we are going to develop an IoT system. That system which is trying to understand the air quality indexes. Of course, the existing air quality indexes are there. But in addition to that, we want to add some kind of social mindfulness, in the sense the behavior of the persons, how it is going to influence the air pollution. So this is what basically the ingredient that we have added to the existing systems. We will try to come out with a low-cost IoT system that as well monitor the air pollution, but at the same time try to assess the behavior of the human beings and how it is going to have impact or influences on the air pollution system. So that is what we would like to do in this project. And for this, we will be developing an IoT system, and apart from that, we will be developing some ML algorithms, and of course, we try to come out with a policy document how this particular social behavior or the human behavior is going to help for us in trying to mitigate or trying to lessen the air pollution or improve the air quality indexes. So basically, we like to look for how a socially mindful IoT air quality monitoring system can be built up. So we are giving something like value measures. Value is basically air, measures is something like awareness or some kind of consciousness among the society. So we would like to build up a IoT technology system which will try to improve the air quality indexes from the air pollution perspective. And at the same time, we would like to add the social media integrations to the IoT systems, whereby we can quickly monitor this. And of course, I will be discussing much in the afternoon session about how the system can be built and what we want to realize it in the due course of time. Why we are trying to do here is, the big picture of the work is something like this. We have an environment, and from the environment, our sense organs are going to sense the important aspects from the environment, and obviously the sense from important aspects are going to be the choices that need to be done, or choices that need to be made as a good or a bad. In the sense that if our air pollution is very much severe or it is very much hard, then obviously our realization, our understanding, our cognitive levels are also going to be disturbed, and at the same time our decisions will definitely go into either a bad or to some extent to a good extent. So basically, our air pollution is also going to be an important factor in making some decisions in a wiser manner, and that will influence that. So ultimately, we want to realize that IoT system, which is trying to look for the particulate matters and how that can be influencing the behavior of the humans in the society, and how we can try to improve it further. And of course, this is not the only work which we are doing. Already there are existing works. In fact, this project proposal was being done almost in 2019. We have put this, submitted this in November 2019. We got the approval very recently. And in fact, for the last 2-3 years, people across the different countries, they are also trying to implement a very similar kind of work. and how the systems can be built up. So during the last 1 week to 10 days, myself, the professor and the professors of our department, we have come out with designing a coursework how smart monitoring systems can be built up for the IoT systems to be developed. And apart from the course designing, we also come out with some kind of developing a 5G sensor node. That sensor node which is capable to capture the multi-parameters like the gas sensors, PM sensors, and the DHC sensors. From the data collected, we would like to process it, and of course, we would like to add some components. This I'll elaborately discuss with just a big picture which you are envisioning at this time to develop the sensor node in collaboration with the Macquarie University and our university, and we'll come out the final output of this one in the later stages. The realizations details I'll come out in the workshop, so that workshop the hands-on activity will be based on developing such kind of system. So that we'll discuss it in the afternoon session. For now, I request Professor Subhas Chandra Mukhopadhyay who is visiting our university as part of the sponsored project. And in that, already last week we had one seminar activity, and this is our activity number 2, that is conducting a workshop in building up designing and developing the IoT system for air pollution monitoring and how that system can be realized for a better aspects. So may I now request Professor Subhas sir to please come forward and deliver the session on some of the research aspects. One second.
Thank you, Nagendra. Good morning, everyone. So, what Nagendra has presented the project under which we are working, myself, Nagendra. So, this is the first event we are having. So, today what I will be presenting is not exactly related to the project, but we will get some kind of overview how the IoT system can be used for monitoring different parameters. So, the first session I will be basically explore 5 projects which you will get a flavor that what are the different things can be done. So next session there will be another specific project which we will be more in detail. Of course, with time we will be concentrating more on that. So as you see that the social aspect is involved, just from the development of the node, how the measure parameters can be related to the human behavior and so on. So as Nagendra mentioned that I'm from Australia. My university name called Macquarie University. Many of you may not have heard that name, but one of the important aspects of our university is that the contribution in terms of the science and technology. So you all know that we are using Wi-Fi. Almost everybody uses Wi-Fi these days. It will be very difficult to find someone unless they are living in very remote places in India. Everyone has got phone, and then without Wi-Fi, it's pretty hard to think of our life now, isn't it? And in fact, if you remember that COVID-19, when university was almost locked down, and I was in Sydney, we used to go only 1 hour a day, and that's the permission we had, and we survived because of the Wi-Fi, isn't it? So this Wi-Fi actually was developed by our professors in the late 90s. So Professor Davis Callan and Professor Neil Oesti, so they are the 2 important researchers who were actually involved. So Professor Davis Callan was head of the department, our Department of Electronics, and Professor Neil Oesti, he was a researcher. Actually, he has a company now, and I will be at the end of this presentation, I will show you that one of the conferences which we are organizing in Sydney, in my university. Professor Neil Oesti is one of the key speakers, and he will be talking about the long-range Wi-Fi. So we are talking about the LoRa. LoRa stands for long range wide area network, LoRa 1. And we all know that Wi-Fi we use today. I mean, if you are in a building, 20 meters, 30 meters, go outside, you actually get 100 meters if the gateway is located nearby. But have you ever imagined that Wi-Fi can be available like 3-4 kilometers? So we is working on that. So it will be quite interesting. So my university is in Australia. Most of the university are called state-funded university, like University of Hyderabad. The money comes from the center. So it's pretty similar because only one university in Australia is private university. I don't know, you might not have heard the name of Bond University. Bond University is the only private university. But even though everybody is government university, it's like run by private organization. Okay, what does it mean? My job is not secure. Anytime I may lose my job if there are not enough students. So I am the head of the department of Mechatronics, but Mechatronics, if my enrollment goes down 50, university might say that, Subhas, you need to think of some other job. So that's what the thing is different from India. So here, university, government university, professors work hard, but others may be thinking, my job is security, like, retired. So that type of thing is not there. That's the difference. So we actually like to improve our ranking. So a lot of things are happening in terms of the international ranking. So my university international ranking this year, as per QS, is 130. They spend a lot of money on making the ranking better and better and better. Okay, I don't say that they do something bad, but that's the way it is. And in terms of the Australian ranking, it is number 10. So this is this university established in 1964. So just last 2 weeks back, Vice Chancellor invited every staff for a kind of a lunch, the 60th anniversary. So it is equal to 24 is the 60th anniversary. Okay? Sometimes we get 3 2. So I will cover few topics which actually we did in recent times, which you will get some flavor what type of research happening in my lab. So 4 different talks, IoT based, all actually IoT are involved. So IoT based water movement, study of water movement, robotic surgery, implanted sensors, and drones. So first, so my group basically we develop, design, develop different types of sensors. Okay. So my basic background is slightly different than Nagendra. So Nagendra is a hardcore computer scientist. Okay. It's very difficult to find somebody like that who has got a lot of interest in sensors and can comfortably work with sensors, which is very, very rare. Okay. People don't understand because many of you are doing computer science degree, and if I give you embedded processor, microcontroller, and sensor, you will be thinking that when the time of the day comes, I will go home, isn't it? But he is something who is very comfortable. On the other hand, I am a hardcore electrical engineer, where I did my bachelor degree from Jagadpur University, Kolkata. I am a Bengali, and then my master's from IIT Indian Institute of Science, Bangalore. And I worked for 2 years, went back to Jagadpur, did my PhD, then went to Japan for 29 years. I am outside India. I am a hardcore electrical engineer. So my students, they basically hate programming. Things are changing last few years. I can see slightly my engineering students are doing well. They are having more and more. They say email AI, which is basically like bread and butter for every day. But still, the engineering students lack the passion and the expertise of computer programming. So we were struggling. So when Nagendra came to me, I was in New Zealand in 2010-11 time. My students, they were doing something in engineering system, but they were struggling to develop the computer program. So if you think of even IoT basically data comes from sensor. But once the data comes from the sensor, it's basically all data. So that means data analytics part is absolutely important. If someone says, I do not know how to actually process the data, system will not. So it's a system, isn't it? Everything becomes a system. And if you think of the system as a family, every member, if do not cooperate, family will be ruined, isn't it? That's what IoT system. So hardware, software, seamlessly they need to work together to make a system. If somebody says, I don't do hardware, I don't do software, if somebody says, I don't want software, I don't want to work on hardware, things will not go well. So sensors are a very important element of that family. Whatever you do, IoT, if you do not know where your data is coming from, I would say better don't do it. Because if you do a lot of programming, develop different algorithms, but you do not know where the data is coming from, you will get rubbish. Because you think of a box, input and output, always you say the transfer function between the output and input, the relationship. And if you give rubbish input, you actually get rubbish output. If you think of that somebody with no background, nothing, can do something excellent, of course, Bill Gates and few others there, but in general, not. So that's the way it is. So sensor is very important. Why? Because if you think of you want to improve something, you need to know what I'm improving, and that measure data. Okay, that's the value of the current system. That actually given by the sensor. So that's why sensor is very important and it's the fundamental. So we use in a day-to-day life, we use lots of different types of sensors. Of course, human being is blessed with 5 different sensing organs, and that's the best which we cannot replace. Some people they need to have some help. So in my lab, the whole idea of whole project is to design develop different types of sensors which actually benefit either human well-being or the society or any kind of scientific contribution. So that's what our objective of our lab. So we actually do in 2 different ways. So left hand side what you see is that standard sensor readily available in the market. So when you actually get that sensor, buy that sensor, you need to make it a system. Because that sensor will give you some signal, only when you apply some kind of voltage, you get some signal. Of course, we always look for the electrical signal, because that's the best way, because you can collect it, store it, process it, transmit it, and whatever information you could do. So here some sensor, temperature, humidity, and also this is the EEG sensor. Last few years, actually, I'm very much fascinating on how the human can be influenced by external factors such as like a music, such as like some kind of other thing. Unfortunately, even though last 3 years I have got students working on that, all final year project students, they are not getting good amount of result to publish a paper, but I should have something. This sensor, what you see, they are actually all fabricated sensors. So my PhD students, when they come for a PhD, so PhD in Australia, in my university is 3 years. Okay. So when somebody joins me as a PhD student, I write down the date of completion. The reason is, so you are all University of Hyderabad, Central University. I don't think you pay any tuition fee. Do you pay any tuition fee? You don't, isn't it? You pay? Okay. So
nominal. Nominal pay.
Nominal.
Just for saying that you are paying.
So I'm sorry, I just wanted to compare those pay. So in Australia, my university, right now the tuition fee for a PhD student is $50,000 per year. So $50,000, one Australian dollar is roughly like 50 rupees, it's like 54, but you can take 50 rupees. So you can say 5 lakh rupees per year. When a student comes to the PhD, usually his fee or his hard fee is waived. That means university says you don't need to pay, because the university pays for that. But that is for 3 years. If the student takes a single day to submit his thesis late, so 50,000 divided by 365, so around $128 per day is to be paid. Okay, and that's not joke. So few years back, I got a bill. So around like a $488 some dollars. I thought, what is this bill? Invoice? What is this invoice? So one of my students, she submitted the thesis on Thursday, but it was not submitted because the process is there. So like some dean who is a higher degree, dean, he actually declined it. So because of that, it came on Monday, and then Tuesday she submitted finally. So 4 days late, because of that invoice. So anyway, I had to write 2 emails and finally it was waived. So every day, that's because after 3 years, university take away your wage. So there is no more wage, so you have to pay. So that's the thing. So in my university right now, tuition fee is like that. If a student comes to do scholarship, PhD, he or she gets a scholarship. The scholarship value is at the moment is $35,000. So they get $35,000 per year, which you may say if you convert into New Zealand Indian rupees, looks very good. Okay, like roughly like 2.5 thousand, so like 1,25,000 rupees. But in Sydney, that's basically not much. So my students always ask for tutoring job, so some extra money, and I always add something. So that's the problem. So PhD students, they need to make something. So most of the time, our students actually, my students, not everybody, my students actually target some kind of application, sensor-related application. If they want to do PhD on sensor, and we design and develop sensors for specific applications. So that's why the right hand side takes some time. Last few years we are working more on the flexible material based sensors. So flexible material based sensor is slightly different than MEMS. So here you see that flexible material, your base is some flexible material called PDMS, PET or some other material, and you have got the electrode which you design either carbon nanotube or graphene, graphite or some other material. You sometimes can use silver or gold. As you see, this is like a compressed form. So if you press, that means you introduce some kind of stress and strain that changes the dimension, and that's actually another parameter. So this flexible material is very good candidate for wearable clothes. So a lot of emphasis has been in the recent times on monitoring the human parameters, okay, for their wellness, for their safety, for different other applications. So we could actually fabricate both MEMS-based sensor as well as flexible-based sensor in our university. Especially the flexible material-based sensor is very simple to fabricate. You do not need a high-end infrastructure. So that's one of the very positive things for the flexible material. So here one of the like CNT, carbon nanotube and PDMS based sensor. So there's the process, and as you can see, you can do it within the lab within a day or so. You don't need extra facility. So effectively, as I said, we always like to make the sensor as IoT enabled sensor. So that means the sensor what we develop, they should be IoT enabled sensor. That means the data will be available in the cloud. So if you see this is the standard diagram for a IoT enabled sensor. So you have the sensors coming at the most important element, measuring some parameters, and those parameters you need to transmit. So you need to have certain kind of wireless communication. Now that wireless communication, depending on your system, you can have anything. You can have like LoRa, which we are talking about, long range. You can have Wi-Fi. You can have Zigbee. You can have many other ways. Okay, sometimes you can have GSM. Sometimes you can have any other method. Ideally, that data should be coming to the local gateway. So the local gateway is very important. So local gateway, depending on the range, you have local gateway need to be located. So if you are dealing with LoRa, where it gives a range of, ideally it says that infinite, but you do not get more than 5-6 kilometers. Okay, so both many times they boast that it can go up to 15 kilometers or so, but it never goes. So we realize that it goes like 2 kilometers to 2.2 kilometers without any data loss. But anyway, so theoretically you can have a long range. So you get a gateway, you have to have strategically placing your gateway so that you get the data. Most of the time it is like a star network. You know the star or mesh, so you hopping things. Usually LoRa gateway is not designed for hopping, so you get the data of the star. So you have the gateway, and then the gateway needs to be connected to the cloud. So that's the gateway part. Gateway is connected to the cloud, and the cloud means like server, data should be stored there. So you store the data, and then you want to use the data. So you then access the data. Now you may actually think of that, I should have everything in my system. So what I mean, if you see component wise, you have got a sensor, you need to install the sensor at strategic places. You have to have, of course, hardware communication there, wireless communication. Then you have the gateway, which is different. So sensor is located at some point, gateway is located at some point, so this is at some other place. Then the gateway is connected to internet, which is also located at some point. And then you are accessing. So if you think of the whole system, they are actually not under your control. Okay? So in our case, this gateway does not belong to us. Now you may say, why does it belong to us? It depends on your application, isn't it? So suppose you think of that I am monitoring something within the University of Hyderabad, and the Vice Chancellor agrees that okay, I will pay money for this gateway. You may have few gateways located within the University of Hyderabad. Your server, computer science department will say that we must have the server. You have the server here, everything is good. Okay, you can have everything under control. But if you say that okay, actually I want to see how the traffic is going in the outer ring road. Okay, how the traffic is actually happening outside the university in the Bachipuri whole area. Then you have to go outside. You cannot have the gateway within the university because the range distance is too far. you must have gateway somewhere close to the nodes. Then you need to take permission, or you may have to see whether any kind of private subscriber or private company they are already existing gateway. Like in Sydney, there are lots of gateways available, but all belong to some private companies. So you have to ask them, can I use? They will say, yeah, you can give money, 1 month, 2,000 rupees. Okay, your project has money, fine, you get. But problem is, you may say that money buys everything, but actually not. Why? Because you generate your data. Now the data going to somebody's gateway. It is like your money, you are putting it to the bank. You all are actually getting scholarship, you might have done some term deposit. Term deposit, if you do 1 year, if you go to the bank will come after 1 year because you have done term deposit for 1 year. Similarly, they got the data. Once they get the data, it's my data. This is my data. Then what you need to do, you have to beg to them that can I use my data which I generated? Then they will say, yeah, you can take a subscription monthly or yearly. You understand the problem? So that's what happened to us. Okay? So you can actually access the data by giving some fees. Now sometimes you may say that, oh no, this is a project, we do not have actually much money because we thought everything is very cheap or free. So can you actually say, okay, it's academic purpose, we can allow you, okay, you don't need to pay, but tell me what is the project duration? 1 year? Okay, you gave data 1 year free. You understand? So that type of problem. So the issue is not only money. The issue is here you may generate the data. The gateway is getting your data. What's the guarantee the gateway, while it is storing, not doing something? Isn't it? So in the wireless communications, when we talk about the security, most important thing is the trust. Okay? They might change the data. So there might be some kind of doctor there. So that's the big problem. Okay? So there are lots of issues when we talk about the IoT, and that's why the IoT is not that simple a project you can implement. When you think of a complete project, there are lots of issues. That's why last week when I talked about the sustainability, those are the issues you need to keep in mind. Anyway, so first project I will talk about for IoT-based study of water movement. So one of the projects which we did was where is all the water. Okay. Now this is actually applicable to everywhere, every country. So this we did in Sydney, New South Wales. So as the name suggests, you may say that we want to know where is the water, isn't it? So exactly the same situation everywhere. So what happened? If you think of that Hyderabad city, the water drilling supply. When you open the tap, you should get the water. But if you don't get the water, you may actually get angry with the politician. Okay? Revan Reddy, what does he do on the politician? Anyway, so everywhere is the same problem. But if you are not engineer scientist, you think of that what actually is happening in the system. We get water from them. Okay, already there are water in the lake, river, sea, whatever it is. Some waters are not actually drinkable. But if you think of river water, lake water, and the groundwater, then we get the rain. That's our source. And then we use the water. Now, when you use the water, your house is not located from the lake very close. So it has to come to the pipes, isn't it? Or it has to come to some other method. We use water for our drinking, for our other usage, for our agriculture, for our industry. So lots of water are used. So input and output should be balanced, isn't it? Now, what is happening in New South Wales? So these are the different headlines you see that New South Wales, so NSW for New South Wales. So that's the one of the states where Sydney is the capital city. Okay? So Australia has 6 states and 2 territories. You might have heard. So 6 states, 1 state is the New South Wales. Another state Victoria, where Melbourne is the capital. Another state is Queensland, where Brisbane is the capital. Another state called South Australia, where Adelaide is the capital. One state called Western Australia, where Perth is the capital. Then you have the territory called Northern Territory, where Darwin is the capital. And then you have Australian Capital Territory, where Canberra, the capital of Australia. So, and then we have Tasmania. So, you will see that water New South Wales blames transmission loss. So, water supplied in New South Wales called Sydney Water. Okay, that's the company. So, we have to pay money for usage of water. Okay, I don't know whether in Hyderabad we pay. Still maybe paying. No, yeah, we started paying. So, things are changing. When I was in India, water was free. So things are changing, everything. Now maybe after 2 years we have to pay for our air. Okay, it's very important. That's the only thing you get free at this stage. But if you ask like trace air, you may have to pay another 10 years time. So they had the input and they saw that actually when the city water gets the bill, sends the bill that how much water is consumed, they found that like somewhere 20% changes. Okay, 20%. So that means input and output, there is something. So you may say, okay, actually the pipes get burst, water leak, some other problem, all these issues. But those issues, even you take into account, there is a problem of 20%. So that's why we got the project. So this project is like a $1 million Australian dollar. So we actually, so there are different rivers who actually supply the water. So every river has got some unaccounted water. Now you may not be the 20% is the loss, but it's the accounted rate problem. So somewhere something happens, we are not able to take into account. Okay, that's why this difference is coming. So usually these are all the name of the river. So Macquarie is the river name, Murray River. So they are the river, and you see some river 5-6%, but some river as high as 26%. Okay. Now therefore, of course, there can be some debate how the water is measured, all these things, and how the usage water is measured. Of course, usage water is measured properly because every household or every company they clean, so there is a water meter. But in terms of getting actual water input, so you may not actually know. So there can be some debate on that, but that's it. So this project is a multi-university, multi-disciplinary project. So here you see the name of the university, ANU, or Australian National University, UNSW, University of New South Wales, and MQ Macquarie, and then there is a research center of data research center of University of Sydney, and NSSN stands for New South Wales Smart Sensing Network. They are basically like IEEE, but IEEE of course worldwide, they are only in New South Wales. They are like a kind of a broker. So broker means like industry, they want to get some problem to be solved. University, they have the resources, research capability, research infrastructure, so they just match. Okay? So that's why this was came to them. So effectively that's the thing. So I will tell you a little bit of what people are doing. Now, ANU, as Australian Research University, National University based in Canberra, they are very strong in satellite. Usually what government does, so every government, okay, whether India or anybody, every government, they want to know how much is the groundwater. So that's the main source, isn't it? And the groundwater with time goes on evaporating and usage, so they go down. Now how do they know? So they use the satellite. So satellite image, they actually can analyze using the satellite image, and they know where can be the groundwater, how much deep on the surface. So after 2 months, 6 months, 1 year, they can actually analyze. Okay? So that's the data government designed because the satellite data. The satellite has a lot of different applications. So that is one of the project. This project partly was done by the ANU. So ANU contributed based on the satellite image. But one of the problems of the satellite image, as you think of satellite, located a little bit top. So the lowest orbit satellite is 200 kilometers on the Earth surface. Now satellite, when the satellite takes the image, it is not possible like few meters. They may take one point here in University of Hyderabad, another point will be 100 kilometers far. Now 100 kilometers is very long distance. So that's why spatial resolution is a problem. But if you think of whole India, you cannot actually go for that resolution. You get an average idea. So that's why this is very good for country point of view, but not for spatial resolution. Another group, this is actually happening quite interestingly. So that's a gravity sensor. In fact, India government with Australia, they have got some kind of annual funding, and it's quite a good amount of money, almost $1 million funding. So they get some funding on this. So this is done again another group of ANU, Australian National University. Now gravity sensor comes from the gravity. So everybody knows like G, isn't it? G, 9.8. Everybody knows 9.8. But have you ever seen that actually it can be 9.8, 1, 2, 3, 4, 7, 8, 9 up to 10 digits? I actually did not know before I meet this guy in our project discussion. So each one, so think of that your G is after 9.10 digit, and each digit represents something. One parameter represents temperature, one parameter represents humidity, one parameter represents water depth, all these things. So they are working on the making sensor which actually measures the gravity, G, okay, with that precision. You understand? So that type of thing. I mean, few years back, before the meeting, I did not think that, oh, okay, 9.8, you know, what is the so deep? But then, when this guy gave a presentation, then, wow, okay, so some new learning. So what actually they could see, they could actually tell under the ground how the water flows with the G measurement. Okay? I don't want to go to the mathematics because lots of mathematics are involved there. So they actually tell like that. Now, in order to measure that, they need to have two G sensors located around 10 to 15 kilometers apart, because they have to measure the G. One G will not have. So if you get like 9.815, that file with respect to what? So they need, one is that they have to have something like that, two G sensor, and also they need to have a reference. See, sometimes when you talk about the sensor, some sensor gives us absolute value, but most of the sensor gives us relative value. When we have the relative value, we actually need to calibrate, isn't it? With some standard value. So they need some kind of standard value. And that's why this is something 10. And then two sensors, if you keep close to each other, it will not give anything. Around 10 kilometers apart. So again, your spatial resolution coming like 10 kilometers. So satellite, your spatial resolution are like 200 kilometers. Now the gravity sensor, your resolution is like 10 kilometers. So 10 kilometers now, if you think of University of Hyderabad, you have to go like almost like a high-tech city, isn't it? So then what happened in between? So that's the problem. So this is another important thing. Another group, University of New South Wales, they have bore sensor. So you know groundwater. Groundwater, how do you know that groundwater is changing with time? So you need to make borewell, and you need to have the sensor installed there, which can be 10 meters, 15 meters deep from the surface, and then they measure the change of the water with time. So you see here, whenever this is the bore level, whenever there is rain, the level goes up. Okay? Because rain means that it's the input coming, and the soil is absorbing something. So that's what these are the measure. But if you see here, x-axis time, then year. So it does not happen minute or hour or day or week. It's happening like month and year. So you cannot see the change happening very quickly. So now the problem is the time resolution. So earlier two problems, you have the space resolution, now you have the time resolution. So those are the issues. So then they thought that what my university or my group can do. So I thought that my group can do something very cheap sensor. You get time resolution, you get space resolution. At the same time, I am not telling that we don't need them. Okay? We need them, but we can actually help them. We can augment, we can enhance the resolution. So that's what we actually came into this picture. So here this is our system. So what we are telling that we want to measure all the parameters, real time, IoT system, develop low cost sensors, install it at strategic places, and get the data. Internet of Things, we can get all real time data. How much data you want, how many sensors you want. And that sensor, if you can develop something like reliable, rugged, and you can actually say that we do not need to worry for a few years, not like 10 years, it's impossible. Okay, so like few years, then that's the best. So that's what we plan. So all the sensor you are seeing here, temperature, moisture sensor, ultrasonic rain gauge, so rain, real time rain measurement, magnetic flow meter. So if you think of that, suppose there is rain, huge rain. Ultimately, if you think of within the University of Hyderabad, there might be some streams. All the rain goes there. Okay. Some rain, of course, can be a little bit pond or something there, but at the end they will go to the stream. So if you want some flow measurement, you need to have flow meter. So we can actually have the flow meter, and then we need to also have So these are the mainly sensors, and all these things will be going to the cloud. So we need to have the data connected to internet, go to the cloud, and what we will do in the cloud, we will be making some model, something called evapotranspiration. They are coming from two terms, evaporation and transpiration. So evaporation, as everybody knows, suppose you keep some water in a bowl. Okay, in a bowl. You will find that after a few days, the water evaporates. So that's the evaporation. So if you think of lake, river, where water is there, they evaporate with time. But another important part, which is actually the most important contributor for mixing the water, is the transpiration. So if you think of so many trees, they actually lose some water. So it's very difficult to account. So that's what the part. So we thought we will develop a model which will tell us the missing water. So we will do this model. So at this project we got during the COVID time, so very difficult because we are not able to go out of the house. So one of my students who was involved in this project, so he actually within this restriction time, he ordered something and then he made some sensor node. So the water flow sensor, and then these are the soil moisture sensor which goes under the soil, and all these node looks like that, and then it will be solar panel will be powering. So when we develop the node, so you see this is the node inside, so panel is there, inside the box we have all the sensors, and that's the rain gauge. We actually we got some rain gauge from like either Amazon, you can say what it is, but usually they actually don't work very well. So finally we developed with an ultrasonic based sensor from so ultrasonic and then with the level measurement. So and then all the data you see now coming from the Internet of Things. So in the laboratory environment, but because our target was, if you think of the soil property, usually the soil, when there is rain, they absorb. So soil become wet. Okay, that means soil absorb water. But you may say that how much depth I should be studying. So there are lots of literature on that. People usually say that 1/3 meter is the very good implication to tell about the soil property. So we thought, okay, if it's 1/3 meter, so we should go for 1/2 meter. So this one is actually 50 centimeter long and it goes under the soil. Now initially when we developed, of course, most of the things are actually like a sensor fusion. We did not develop here anything. We just bought the sensor from market and put it in. So we did not have so much thought. So when you think of that, putting the sensor, soil moisture, soil temperature, all this, and you put on this pipe, then this pipe goes, and the pipe has got a diameter like a 50 millimeter. You think that, okay, I make the hole, I put the sensor, but we did not think. I mean, that's the common mistake many of us do. First time, we do a lot of mistake, and then we after thought, oh, I should have done this. So we did not realize that this sensor, we should be able to use it if we want to change the place. But as you see here, these sensors are on the top. Now, when you put the sensor, you want to measure the soil temperature. Now, temperature sensor, unless it comes in touch, like for example, for our body, earlier days temperature sensor, either you put in the armpit or in the tongue, it touch our body. Of course, this is infrared, that's different. Okay? So, we did not realize that. And after certain few months, we wanted to take it, we cannot take it. Because all this soil, so this part, they actually stuck so hard, gone. So that's what, I mean, sometimes we can say it's not research, but it's not, it's a development thing. So you have to, we learn with time, so we need to do something. So now another important thing that this type of work has got a lot of practical applications. Now when you have got this type of problem, sometimes you are alone. Nobody is there to help you. Okay? I don't say that don't get disappointed or discouraged by that, but that's the issue. So we asked the university that can we get some place where we install. But university, we realized that actually that does not help us, because we want to measure some properties somewhere. So this place is owned by Sydney University. That's a big area. Only problem, this is a place called Nalabrai. From Sydney, it's like 550 kilometers. Now think of that 550 kilometers, what can you do? So if I send my student, I have to think of their accommodation, I have to think of hiring a car, I have to think of who will drive. My student will drive. I have to think of Australian part, because all of our students are actually international students. Okay? Either they are from India or from Pakistan or from Iran. So whether they have got the license to drive in the country, what will happen if there is an accident? Should I lose my job? So all these things, that is coming. But anyway, so 2 of my students went with 3 sensors and installed. Now, problem is that suppose you have got a sensor node you install somewhere. One is the vandalism. Wherever you go, whether it's a Switzerland or it's a Nigeria, same problem. Vandalism is there. You have to think of. But vandalism not by human. That can be by other animals. Okay? So there can be a big mouse. Come and start the wire. Go on. So all these things you have to think of. So we have to think of some kind of. Also, this area is a area for the kind of a like a cows, like a farm. So big animals, they are also can come and do harm. So all these things are important. And then internet connectivity. So if you think of a big farmland, it's very good. But then you install your sensor, there is no internet. What do you do? So all these things you need to think of. So anyway, so finally we installed there, and then we thought that we need to improve the sensor. What can we do? Of course, this is a 3D print. For anything we use 3D print, isn't it? So you see here that improvement. This is our current sensor node. Now this sensor node, the difference of earlier one, if you think of a pipe, you install the sensor on the pipe. But now we make that pipe 3D printed, and we made it such a way the sensor will go so that the outer diameter remains absolutely the same without any kind of problem. So when you make the hole, it just goes. When you want to take out, you can just take out everything. So that's what we did, and it has got 3 different levels. It's 50 meter long, 50 centimeter long, 3 different levels. So one is around 10 to 15 centimeter, around 30 to 35 centimeter, around 40 to 45 centimeter. So you measure the temperature, you measure the soil moisture, you measure the soil temperature, all these parameters coming there. And then on top of that, you have got a normal combo sensor where you get a lot of other parameters. So ambient temperature, humidity, air flow, air quality, like carbon monoxide, carbon dioxide, and of course the rainfall. So all these parameters you measure real time, and then you decide that whether you transmit every 10 minutes or every 15 minutes, you actually transmit, goes to the, you have got the LoRa connectivity, goes to the data, and then you have got all that. So one of the important things, we have some problem. One of the important things, because whenever you design a IoT node, think of that, it is like our food. Electronics don't work without battery. Okay? Without food we cannot. I cannot speak if I did not have good breakfast, isn't it? So that's the reality. So now you think of that, okay, how can I decide my battery size? Now you may say that sun, okay, solar panel is there, as you see, solar panel is there, but sun may be upset with you and say, I will not see you for a few days. You cannot say that the sun is not there, I'll stop my data collection, isn't it? So now question is how many days? So we have to calculate all the battery current required for the electronics and how much is the average current, and depending on that we decide that 4 days is a good time. So continuous 4 days, sun will be out, usually no. So we decided that. So we use a 6000 milliampere hour battery, 6000 milliampere battery, and this gives. But still, you will be surprised that area wants so much rain, and 7 days they did not have it. So our sensor did not give any data. What happened? 550 kilometers what can you do? So that type of things can happen.
Sir, this completely customized by you for this thing?
By ourselves.
Okay.
It's not exactly customized, but so if you see the picture, so that's our rainfall. So this one comes on top, and this is a. So initially we developed.
Energy source is completely customized.
Yes, energy source is basically it's coming from sun solar panel, and the battery, rechargeable battery, we use 6,000 milliampere hour, which gives 4 days backup. So that means if the sunlight is not there, you can still operate 4 days. But if the sunlight is there, within like 8 hours, it will be fully charged. So we designed that way, and we use a box. So in the beginning, we thought, okay, we can actually design 3D print. But 3D print, everybody uses 3D print these days, isn't it? But I always find that 3D print is good for laboratory, some fun things, But if you do some serious work, okay, like suppose you have got 100 nodes to make, 3D print is not the option. So we have to find something. So this was the standard box available in electronic shop. We bought it. But when you do with electronics, one of the problems which we have here, you see, suppose you measure the temperature, okay? Measure the temperature of ambient and measure the temperature within the electronic box are different. Because if you do not think of airflow, air gets stuck. Electronics working, their temperature increasing. So you find there will be an error of 3 to 4 degrees centigrade if you do not have airflow. So all these things you learn, we get the data, it is not accurate, you blame the sensor, I get a cheap sensor, it's actually not cheap sensor, this is the problem. Your design is the problem. So you do not think of the airflow. So all these things come with experience. So always when your first prototype is done, you never ever expect that you get accuracy which you expected to get. You never. Because you will have some development work, some trials. So first prototype, very good, because you have done a prototype, you are very happy, okay? But you will find that's the starting point for the improvement, and that's always important. This is Arduino based, so we did not use any Raspberry Pi, so Arduino based. So it depends on how many sensors you need to have. So the combo sensor, one of the good things is that it's an I2C connection. So even though you are getting 8 parameters, but you are not using 8 IO pin, so that's really good. So, and then we installed. So you see that we install again the new sensors. Before we do that, you always need to think of that's our laboratory simulating environment. So we need to have a 60 centimeter deep, kind of a soil system where we install it, run in the laboratory for a few days, few weeks to know that things are working. There is absolutely no problem. What are the issues? You sort it out. Because if you go to the place where it's far from your university and install it, you don't expect that you will go again very quickly. So those type of things need to be in mind, and then you see the data is coming. So then we place into different places. Okay? Actually we place in my house also, because when we develop, we are ready where? Otherwise it's not working, in the lab. So we said, okay, I'll use it in my house. So these are actually in my house. This is the farm. This is the farm. That's actually in my house. So and my student, Wakas, is a Pakistani origin student. He is actually in the third year now. So he is involved mainly in this project. So that's the farmland of Sydney University, and the whole, it's a big area, and that's the place where we installed, and the data is coming. So now you will say, okay, you are getting the data. What's the purpose? The big picture for us is to talk about the water loss. Okay? Or in other words, you can say that water loss is happening. We are giving insight that where is actually the water is getting lost. So that's the whole idea. Now in New South Wales, right now you will see that there are lots of places where you collect the data. Government collects the data. So the Bureau of Meteorology. You will see when you open the switch on your television, they will say Hyderabad temperature at 27 degrees Celsius. Now where do they get the data from? So definitely there is some point where they are measuring the temperature. Now that point may not be your house. That point may be in the terminal place, isn't it? So they think of the whole city is that. But actually not. Your house or your neighboring area may be 1 degree more or 1 degree less or maybe even more than that. So but that's the way it is. Now this is the New South Wales situation in Australia, Sydney, 4,673 sites, different area, but 396 only giving the data. So think of that, okay, state of Telangana has paid money that okay, there will be a system in terminal where it will measure the data and automatically upload the data to the cloud where Bureau of Metrology has the access. But many other places they have installed, but they do not actually upload the data. So you may say then what's the purpose? But earlier days, before IoT came, there was no way unless they use some other way of uploading the data to the cloud. So sometimes somebody they have to go and see the reading of the instrument, collect it on notebook, and then email or send it, and then somebody will be as the operator putting the data. Now sometimes they may actually instead of 27, they may actually say 17. You understand? The human error were involved. So those are the different issues. Wherever you go, it's all the level. Somewhere it is 90%, somewhere it will be 70%. But that is the problem because human is involved. So that's the situation. So we thought that we can actually help them developing this type of node. So one of the problem is, I can just tell you one example. You know the projector. Okay? If you buy a projector for your use, this may be 10,000 rupees. But if government, university, any organization done through their system, that 10,000 rupees will be 2 lakh rupees. You understand the problem? So that's everywhere it is the same. I'm not doing the commission. Okay, forget about the commission, even in normal way, because that's the way the standard they maintain. Okay, so this is the problem. So we thought that okay, we can develop low cost, we can actually install and they will be all real-time data measured. But you know, in government, you talk somebody, you see that he can say that when the power is concerned, he is useless. So you have everywhere the same problem. So we have lessons. So we said okay, fine, then do our research. Okay, so we collected and then the study of this is the water movement. So I talked about the source of water. Okay, your river, lake, underground, and the rain. That's the main source. Out of that, only rain is the dynamic. Now you have got the usage where water is used for different purposes. Now in between you have to find out what is actually missing. So if you see the equation, so your equation is that here what are the sources coming and what are the usage, and the remaining is you think of as a loss due to transpiration and evaporation. So this needs to be balanced. So water, whatever the source of water, either your storage will be increased or storage decrease depending on whether the input is more or less. So you need to find, but then you need to validate. Okay. So we are collecting the data. We are measuring data on our own. We are also collecting the data wherever the data is available, and then we are using different modeling methods. When you do modeling, as you know, the modeling means you have some training data, you have some test data, all these things we are doing, and we are trying to see which one actually fitting very well. So here, whole idea is to we want to predict that evapotranspiration. So that's the missing link, because whatever water is lost, we actually say out of this water, some of the water is actually evaporated or transpirated, which was not counted before. So that's the whole idea of this project, and we want to make the error smaller and smaller. So different methods we are using. So here you see support vector machine. So student use different things. So that's what he is doing. My student he is doing on that. And right now we have already 1 or 2 papers on that. And the modeling part, he has made a paper ready. We have to find the right journal on that, because we do not actually do much work on modeling. to find the right journal. So basically the whole idea is that what we want to do is the development of low-cost sensors which can be useful for any organization, either government or the water organization, who can actually use that. And it is not for long term, it is for short term, because life of this can be 1 year to 2 years, not very, very long. And in order to develop this particular model, we need to have many sensors located in an area, because you need to, if you think of the soil property is so variable that if you dig some soil in one place, maybe 3-4 meters apart, if you dig, property will be totally different. So you cannot rely on one node and a very large area, so you have to have many nodes located. And the water moves maybe vertically, water sometimes can move horizontally. Suppose water moving vertically, but there is a rocky place. Then the water cannot, but water will not stop there. Water has to move. So we have to have that both directions thing. So those are the things we is planning to do. But of course, as I said, there are always issues. So this sustainability word is a very big buzzword now. Okay? But it's a very vague. When you actually try to define what is sustainable, you will not get a proper answer. Okay? Because I think that for a project, especially like for example, I have come on this project, smart project, which is valid only for 2 years. Maybe we generate lots of good ideas, but then after that, if you want to continue, project is not there anymore. I will not be coming after that project, time is finished. How can we actually do that? So those are lots of issues. So project has to be sustainable, that means there is a continuous flow of money. So this is one of the important things everywhere. But unless for an IoT project, if you cannot generate revenue from the project itself, it is impossible to continue. So that's the reality. So we have got lots of issues other than the money. So for example, as I said that if you want to install the node, you need to get a particular site which you have got the permission and you have got the authority to maintain something. So getting the site sometimes may be very, very difficult. You may install it. How do you maintain it? Whether you will have some security or something, so the maintenance issues are involved. Then the solar power issues, so solar panel placement. So sometimes you may actually get a good site, that yes, you get a lot of good area, but there is a big tree close to that, and the tree actually blocks the sunlight. Okay, so you cannot have a very long pole to install your solar panel. Now these are all practical issues, and you may say, okay, yeah, actually I did not think of that, but yes, those are the issues. So battery, how much power, and also there is a particular angle between the sun and that particular location. So your panel needs to be properly matched with that angle so that you get maximum hours. So average like 6 hours you get. So you have to see. So that is also important. Now if the students did not see that, or as a supervisor we did not think of that, and just install it, and you install it such a way that solar panel and sun doesn't come at all. Okay, you have a panel, but you don't get any energy harvested. So all these things need to be looked into. When you deal with a microcontroller and Raspberry Pi or any other hardware is one part, but your software needs to get updated. Every time you see that iPhone, if you use iPhone, you get a message, or you did not update it for last 3 months. Okay, 2 a.m. Do I do that? Okay, you say, okay, now do it now. I don't need to use the software. No, you understand the problem. This is a common problem. You use something on Arduino, and then it is internet connected because it's an IoT node. Without your permission, it might actually update it, and then it's not working. You understand the problem? So these type of things happen for us many times, and taking the node, bringing to the laboratory, fixing the problem is a fail of it. So sometimes students, they just don't want to do that. Okay? So very good, do something in the laboratory, don't need to think of some real application, very easy life, peaceful life, but otherwise it's very hard. And then electronics can fail very time. Okay? You might have chosen the best company, but it's not the best component you got. You may be unlucky. Okay? You got something that it was working perfect, but as soon as you install it, stop working. What can you do? Okay. So these are the common problems. And then when you design something, you did not think of so many things. You think these are the good. After you finish the design, you say, probably I should not think of this should have been there. Isn't it? An extra feature. And then you cannot do it again. Okay? So these are the things always. So always when you design something, you have to think of that. How can we actually keep on improving? Because I always find, if you remember, I mean, many of you did not even born that time, we had the Panasonic CD player in 1980s.
Yes.
And see, Japanese company, Japan think that, we are comfortable. And after that, iPhone came, of course, little later, but phone came. Now, can you tell me anyone who actually listened from CD player? No one. But if you think of the Japanese company, they came with the idea in 1980s. If they could have think of, if somebody in the company CEO with a vision has got the future like Steve Jobs did, iPhone would not exist now. Something else. But that's the thing that when you design something, you also need to think of that in the future. What is actually things you need to add? So those are the important things. Whenever you work with IoT, without internet, IoT does not exist. Okay? So internet has to be there. You may think of LoRa, you may think of any other thing, but at the end, your data has to go to the cloud. If you do not have internet, you cannot work on IoT. And demanding internet available at each and every place is a big task, okay? A big ask. So that is also sometimes we have to think of. So, and then if you use somebody else gateway, how do you actually take the ownership? Because you are generating data, somebody is getting the data, that's now become their property, so it's a big problem. So all these things, and then of course the privacy issue. You are generating the data, but then the data goes to somebody. You might have changed the things. Okay, you are accessing them, but some doctor. Okay, and then of course the financial sustainability, and as well as the research. So these are the different issues which we need to think of. Okay, so Naninder, how are we going with time?
We will take break for 10 to 15
Okay.
minutes. Okay. Before that, just small announcement. Okay, thank you. Maybe for the latecomers, in the sense, I'll just brief within 2 minutes. How then the rest of the day, how the program is planned, I will try to disclose that also. So for the latecomers, just please try to understand that this is basically a workshop which has been sponsored by SPARK, Scheme for Promoting Academic and Research Collaboration between India and Australia. In that project, we have received some fund based on the project proposal that we have submitted in 2019. So in that process, there are a series of workshops and seminars and course deliveries too. So at present, we are in that particular process of that first workshop being conducted. And of course, during the visit, the foreign principal investigator, Professor Subhas Chandra Mukhopadhyay, is visiting the university. So here we are trying to do some activities. And of course, we are also developing some course materials. And whatever sir has discussed up to now, which we have at least listened, all those intricacies, all those internal details will be helpful for us to design and develop an IoT system for this kind of system that which we are talking about, that is intervening social perception in the estimation of air quality indexes among the particulates. So when you want to develop that IoT system, the other applications what sir has disclosed is that one, but the same characteristics, same principles, same philosophy and same methodology will be used to develop this IoT system for this particular project in the coming 2 years. So that's what the basic idea. And how the practically it can be realized, that we will discuss in the afternoon session when we develop our own IoT system. So which we are planning, this is what which we are proposing, the 5G sensor node for monitoring the air pollutions of the particulate matters, and that we will discuss it more closely in that. So now we will break for tea, and here lunch is also been provided. Please do join for lunch at 1 o'clock. Then after lunch is over, we will have a hands-on workshop. Whatever the sir has given in the basic diagram, collecting the data from the sensors to the gateway and from the gateway to the cloud. The same thing will be realized, and our research scholars are there. So we will try to show you and we'll make it to some practice with 3 different systems. With the already system which is existing from the company, and a system which you want to design and develop from the scratch with the raw sensors that we have planned it for the 3 hours in the afternoon session. So this is how the plan has been worked out. So please do join for all the activities. Feel free to discuss with professor and as well as the other resource scholars, so that at least some kind of output. And I hope that you will definitely get some takeaways from this particular end of the workshop by the end of the day. And apart from this, there are participants from IEEE sponsored sensor council. We are not ignoring that. We don't think that is different from that one. We are jointly collaborating it, and we are conducting this particular program. So in the process, what I request you is please come forward to take one photograph so that it will be documented for both the activities. So after that, we'll wait for the tea and we'll join for again continue the sessions from the sir. And afternoon session, we'll do the practice, please.